So let's do our partial pressure of oxygen experiment. We're going to make a little magnesium candle. I have these little clip stands that I made plus 5 centimeters of magnesium ribbon. We're using some older magnesium ribbon. It's got some black oxidation on it. I'm not sure, of some kind, but that shouldn't bother us. We just need something that's going to burn and consume oxygen and turn it into magnesium oxide. We're going to put 50 milliliters of water into the Petri dish base. And then our basic procedure is going to be to light the magnesium ribbon, and while it's burning, we're going to cap it with the test tube and make sure the test tube is submerged in the water. The oxygen in the test tube will be consumed and the water should be drawn up into the test tube. I'm going to try and make that a little bit straighter, more vertical. That looks better. All right, let's do this. My torch doesn't work as well as it used to. Almost. Come on. There we go. There's no real hurry here. I'm going to sort of slowly put it over. Let it burn. And then we do also need to let it sit for a while and cool down. And as you can see, at the bottom, the water is being drawn up into the test tube. It doesn't feel too warm. So I'm going to go ahead and mark that height of the water on my test tube with my China marker. And now what we want to do is figure out how much volume that represents. So we're going to have to do the following. We're going to have to measure the volume of the water that up to that point. So I filled the test tube up to my China marker. And that is a volume of, read here, these are terrible test tubes to read, grad cylinders to read, 42 milliliters. And then we need to measure the volume of the entire test tube. That's going to be a two-step process because the test tube is a little more than 50 milliliters, but that's okay. We can do it in 2 steps. All right, so pour that in. And I'm reading 26. I'm reading 33, so that's 59 milliliters. And from those 2 volumes to the mark and to here, I can figure out the amount of the volume that was displaced, and that divided by the volume of the test tube would be equal to my partial pressure fraction for oxygen in the test tube.